Okay, we're going to do products and quotients of rational expressions. So yesterday, all we did was just reduce. Okay. Today, we're going to multiply, divide, then reduce. So products and quotients. Just a quick review to make sure you remember the basics. Right, if I ask you for 4 over 3 times 9 over 16, you can do two things. You can multiply straight across, 9 times 4 and 3 times 16, and then reduce. Right, that's fine. You can even just reduce the 4 and 16, then multiply and reduce again. Okay? Or you can reduce everything and then multiply. In other words, in any combination, as long as when you're finished, you make sure it's completely reduced, it doesn't matter how you do it. Alright? So for example, you could say this is a 1 and this is a 4, correct? And then you can say this is a 1 and a 3. So you end up with multiplying straight across 3 over 4, right? Okay? Now, for division, here's another one. 1/10 divided by 1/15. What do I change division to? Do y'all remember? Multiplication, and what do I do to the second fraction? Flip it. Okay, so 1/10 times 15 over 1. Can simplify now. It becomes 5 fits in there 2 times, 5 fits in there 3 times. So you end up with 3 halves. So those are two just kind of remembering the basics. We're actually going to do the same as yesterday, but with multiplication and division. So simplify. What is a rational number? Don't remember? A what? Anything being written as a fraction. Good. So negative 4x squared over 9 times 27 over 12x to the 4th. Here's the problem with these, and if you're looking at your homework, compare to problems 1 through 4. 1 through 4 can get really messy really fast, because if you look at your numbers 1 through 4, nothing can be factored. You just cancel everything, right? But when you start canceling, what happens is you start to forget things. Things kind of get lost in the cancel shuffle, okay, basically. So what you're going to do is you need to cancel as little as possible that keeps everything nice and clean, and then you can finish at the end. Okay? Try to do as little as possible. Like for example, I'm not gonna want to use these numbers, they're too big. But what could I do that would make the problem pretty simple? I could just make this 1 and this 3. Right? Okay, 9 fits in there 1 time, 9 fits in there 3 times. So now, I could keep going if I wanted, but it's going to get really messy. So I'm going to stop there, and the numbers are smaller and easier. All I have now is negative 4 times 3, which is negative 12x squared, and 1 times 12, which is 12x to the 4th. Okay, I could have kept going. The 4 and 12 can be simplified, the x's can be simplified, right? But it gets messy. So what can I do from here? These cancel, right? Leaving me with a negative 1 on top, and 2 of these cancel with 2 of these. So negative 1 over x squared. That's what I meant by just waiting. Now look over here, before I did any canceling, what's my restriction? What is x not allowed to be? 0. Because 12 times 0 would have given me 0. You only have restrictions in the denominator, right? Number 2. I'm not going to call these out because I always feel like a bingo caller. There's so many letters. So just be real careful as you transfer them to your paper. this is what I'm referring to. Look, if I start canceling stuff, it's going to get really messy, right? So just let's deal with the numbers, okay, the coefficients. And let's get as few as possible. In the numerator, I would multiply the 6, the 2, and the 3. In the denominator, I have a 14 and a 3, right? So just to be nice and easy, I'm just going to cancel these 3's. Because that's simple, right? It gives me 12 in the top and 14 in the bottom, right? And not anything's messy, right? You could keep going if you wanted, but you're risking making a mistake. So now in the numerator, okay, if I look at my coefficients, I have a 6 and a 2, so I have 12. Now let's count up the m's. I have 1, 2, 3. So 3 m's. Count up my n's, 2, 4, 6. And I have 9 p's. You try the denominator. I have a 14. I have 3 m's, 2 n's, and 2 p's. And they can just cancel from there. Simplify. It's like a fraction. Right? 2 fits into both, so you're looking at 6 over 7. The n's cancel. You're going to subtract 6 minus 2 is 4, so 4 n's on top. 9 minus 2 is 7, so 7 p's on top. That's your answer. If you go back and look at your restrictions, you need to look at it before you cancel, right? So if you take a look here, m, n, and p can't equal 0. Okay, number 3. Division, right? Okay, and a misconception kids were making today was they tried to cancel before they flipped. Can you cancel? Could I solve a division problem? For example, this. Okay, 1/2 divided by 2/3. Can I cancel before I flip? No, you flip then cancel. Flip then cancel. Okay? Otherwise, you're in the wrong spot when you cancel them, right? So then let's rewrite this. So we're going to have 7x squared over 9y. What does division turn into? We decided when we're dealing with fractions, turns into multiply good, and we find the reciprocal. So 15y squared over 4x. Change division again to multiplication and flip this one. 6xy over 35. Okay? Now again, we run into that same battle. There's nothing to factor. We just need to plain old reduce. The least things that you can reduce, the better it's going to be. Because again, this gets kind of messy. I'm going to take the 7 away with this 35 and make it a 5. What else can I do that's easy? That gives me a 15 and a 6 here, but I'm gonna pick the 15 and the 5. So now all I have is a 1 down here, nice and easy. And then what does this become?
3.
And I'm going to cross out the whole thing and put 3y squared. And now my numbers are very manageable. 18 in the top and 36 in the bottom. If you want to keep going, you can. I'm just going to be careful and stop. So I've got a 3 and a 6, so I have 18. How many x's do I have? 2 and 1 more. So 3 x's and 2 and 1 more y, 3 y's. You try the bottom. 9 and 4. What do they make? 36 x and y. Okay, reduce that. How many 18s fit into 36? Yeah, 2. This becomes 2. These go together, leaving me 2 x's in the numerator. These go together, leaving me 2 y's in the numerator. Now let's deal with my restrictions. You're going to look right here. That's the other place. Do I look at my restrictions, my original problem, or here? You look here. So what x can't be 0 and y can't be 0. What are 4? This one doesn't look anything like the others. How come? The others were basic and straightforward. Do what? I still don't understand. Yeah, there's trinomials. Thank you. I'm sorry. There's trinomials. Well, what do you think I should do with those trinomials so that I can cancel stuff? What did we do yesterday? Yeah, we factored. Same thing. It just looks a little different. So factor the numerator and the denominator of the second fraction right here. So this will stay the same, just x minus 3 over x minus 5 times, I'm going to factor this to give me x minus 5 and x plus 2. This becomes x plus 7 and x minus 3. Now what do you think?
X minus 2.
Yeah, I see it. Thank you. I'm sorry, guys. This should be a minus 2. Thank you. What do you see now? What can we do now? Perfect. We can cancel. So we're going to cancel the 5s. Cancel the x minus 3s. Easy, isn't it? And you're left with an x minus 2 over an x plus 7. Do the x's cancel right here? No. Do not cancel. It's not an x. It's an x and a 2. Okay? Now to look at your zeros. You're going to look right here. If you'll notice, in this situation, x can't be 5. In this situation, it would be negative 7. And lastly, this would be 3. All of those give us 0 in the denominator, which makes the problem undefined. Number 5. It's another division problem. So what do you have to do with the fraction, the second fraction? Flip it, yeah. So I'm going to go ahead and factor the first fraction out to make it simpler. In other words, I'm going to take a 2 out of here. If you divide a 2 out, you're going to get an x. And what are you going to get here? Kids made a mistake with this when they were used the other day. You're going to get an x and a 1. And then here you're going to take a 5 out and get an x minus 3. I'm going to change this to multiplication and flip it. So this is x minus 3. Okay, try this. Try to factor it. What can I take out? Come on, what can I take out? A what?
X minus 2.
I can take out a y, right? Out of the top?
Oh.
Yeah, you're saying what's left. I get it. And when you take a y out of this top, you get x squared left over. What happens when you take a y out of here? What do you get? A 1. You understand how come? You're dividing essentially. x squared y divided by y is x squared. Y divided by y is 1. Now then, can this be factored again? Good. You notice that I'm just going to put a clean line through it and refactor it. And then cancel what you can. The x minus 3's go away, the x plus 1's go away. And then top, all you're left with is 2. In the bottom, you're left with 5y and x minus 1. You can leave it like that. There's no reason to keep going, right? You can glance at it and know you can't factor anything else out, so you're good. Now let's take a look for my restrictions. You're going to look before you cancel, which would be this step. So in this situation here, x can't be 3. What about right here? How about y? What can y not be?
0.
Good, because if no matter what this is, 1 times anything, it would stay the same. 2 times anything would double it. But what's going to make it 0 is 0. So y can't be 0. X can't be 1 or negative 1. Number 6. What do you notice about that first fraction? What are both of those? They sneak up on us, don't they, sometimes? Right? If you see a binomial and they're both perfect squares, there's a minus in the middle, right? Okay, it's one of those things that just kind of every now and then show up and you're expected to kind of remember it, okay? But yeah, that's a difference of perfect squares. So then this is rewritten, remember, because the square root of this would be 4a and this is 3. This would be 4a plus 3 and 4a minus 3, remember? And then this would be an a and a 7. So a plus 7 and a minus 7 times a minus 7 over 4a plus 3. Cancel what you can. And you're left with 4a minus 3 over a plus 7. Can the a's cancel? No. It fit into all 4 things. Right? A unit can cancel like a set that are in parentheses because it means it's been multiplied. What about my restrictions on this one? 2 of them are easy.
7.
Yep. These 2 are easy. 7 and negative 7, right? This one's a little harder. Anybody know it just by looking at it? Negative 3/4. If you're not sure, think about it. I want 4a plus 3 cannot be 0. Now what I'm thinking in my head, it can't be 0. Move the 3 over and divide by 4. So negative 3 over 4. Those are your restrictions. Number 7. 2x squared plus 9x plus 10 over x squared plus 5x plus 6 divided by 2x plus 5 times x minus 1 over x plus 4 times x plus 3. Okay, what's hard about that first fraction? What does it have? Yeah. You have to flip it. Good. And this numerator right here has to be factored in. It's got a leading coefficient. Some of you still struggle with that. Okay? That's the rainbow where you multiply this finish so you don't mess up, what do you have to remember to do? Divide it back out. It's like a big ring. It's going to go all the way around. Okay? So, let's take care of that then. Remember, we're going to flip it as well. So let's factor this. We want numbers that are going to, you try it. Let's see. See what you can do. Try to factor that top. Factor it. You want numbers that multiply to give me 20 and add to give me 9. What two numbers are they? 5 and 4. But guys, watch. If I try to make my answer x plus 5 and x plus 4, when I go to check it, when I go to check it, 4 and 5 make 20, not 10. So I know I did something wrong. So, right, that's because when you get these two factors, you're not finished. If you do the rainbow, you have to divide it back out also. So divide by 2x on both sides. So therefore, the top problem factors is 2x plus 5, and this cancels, and x plus 2. This becomes x plus 3 times x plus 2. Change division to times and flip it. I just changed division to times and flipped. Now cancel everything. Cancel what you can. A lot cancels. And label your restrictions. What about the weird one? What's my restriction right here? Move the 5 over, so negative 5 divided by 2, negative 5 halves. Okay? That looks like a big mess, right? Write it up. Actually, it looks a whole lot harder than it is. It's actually very simple. I'll show you how to do it. What do they call that? That's called, when you have a fraction on the top in the numerator and a fraction in the denominator, what's it called? It starts with a C. It's actually called a complex fraction. Okay? But if I asked you to do something just really simple, if I told you 1/2 divided by 1/3, what do I do in that situation? Yeah, so you see that when you get a weird, crazy, complicated problem like that, make it easier and apply the same rules. Okay? This is the same thing, just the answer. So remember, you take this and you flip it, and this is 3 over 1. The reason you flip it is because this is what this means. 1/2 divided by 1/3. Isn't that what that says? 1/2 divided by 1/3? 1/2 divided by 1/3. So you just flip the second. That's the reason. Okay? It just looks fancier. So go ahead and do that. Flip the second fraction real quick for me. And take this and flip it. So you're going to have 3x squared minus 27 over 6x plus 18. And then just factor everything and cancel. You get x plus 3 times x plus 3 in the numerator. Take out a 2. x squared minus 9. Here's the deal. You'll notice that these two cancel, right? But if I don't go ahead and factor them all the way, then it makes my zeros hard to find. Right? Remember to find our zeros, you factor all the way. So this is actually 2 times x plus 3 and x minus 3. It'll be easier for your zeros. It doesn't matter, they cancel, but it'll matter for zero purposes. Now cancel everything you can. X plus 3 goes away, x minus 3. Now this is where it gets confusing because there's so much left over. What's actually left in the numerator? An x plus 3 and a 3. In the denominator, I think I just have a 2 and a what? 6? So can I reduce one more time? Sure. It's okay that I didn't catch everything in the beginning. Just don't box your answer till you're done. So then the actual answer is x plus 3 over what? 4. And if you found it first, it's fine. It doesn't matter where. Now for your zeros, x can't be 3 or negative 3. Okay, we have last one. Or not. Oh, sorry, there's 9. I didn't do that intentionally. I really wouldn't. I wouldn't get your hopes up like that. Sorry. Gosh, I'm sorry, guys. Last one. Can you cancel right now, or do you have to flip first? Flip. Try it. Don't cancel till you flip. If you want to cancel this right now, you can, or you can wait, whichever way you want. This x goes away and this stays x. So you have an x and an x plus 3 on top and nothing left on bottom, except a 1. So you can divide it by 1 or not. If you only have a 1 left in the denominator, it doesn't matter if you leave or not. If you only have a 1 left in the numerator, it's mandatory. So our restrictions, x can't be 4, negative 5, and what else? What's missing there? I'm missing 1.
0.
0, right here. Good.